Hey, welcome! So today we are tackling a wild idea, something that sounds like it's straight out of science fiction, but is pulling in some very real-world cash. We're talking about putting giant AI data centers into orbit. You have to wonder, right, why are some of the smartest investors on Earth pouring staggering amounts of money into this? Let's get into it.
So let's just start with this number, $1.1 billion. That's the valuation for a startup called Starcloud. And get this, it makes them one of the fastest companies in history to hit that unicorn status.
And their promise? Well, it's pretty incredible. Why bother building on Earth, right? Just go to space. You've got limitless solar power, it's totally free, and the vacuum of space? That's perfect zero-cost cooling for all your hardware. No fighting for land permits, no dealing with angry neighbors, just pure, clean, uninterrupted computing power.
And that pitch, it is seductive. So seductive, in fact, that it's attracted some of the sharpest investors on the planet. We're talking big names like Benchmark and EQT Ventures. They're clearly buying into this vision of a future powered by orbital computing.
But that brings us to the real question we have to ask in this explainer. Is this vision the logical next step for artificial intelligence? Or is it something else entirely? Could this be the most compelling and most expensive story ever sold to a roomful of investors? Let's find out. To really understand this incredible story happening up in space, we first have to talk about a massive crisis that's unfolding right here on the ground. Because the real reason Starcloud has a billion-dollar valuation, it actually has very, very little to do with space at all.
Okay, just look at this chart. By 2030, AI data centers alone are on track to eat up 9% of all electricity in the United States. 9%. Our power grid was never, ever designed for that kind of insane focused demand. It just can't handle it.
And it's not like we can just build more power infrastructure overnight. I mean, the lead time to get just one of those critical transformers is now 3 years. If you want to get a permit for new power lines, good luck. That can take even longer with all the lawsuits and reviews. And building a new power plant? Forget about it. You're going to face a mountain of local opposition. The entire system is just completely bottlenecked. So here's the really crucial part. While all these big tech companies are publicly painting this beautiful picture of infinite, clean, green AI growth, what they're doing privately tells a totally different story. Amazon just bought a data center campus powered by a nuclear plant. Microsoft is making deals to help restart 3 Mile Island. I mean, come on, these aren't the actions of companies with a ton of options. These are the desperate moves of giants who are literally running out of power. Okay, so we've established the motive. There's a huge power crisis on the ground. So now, let's put on our detective hats and really investigate this orbital solution. Because when you start to look at the actual numbers behind Starcloud, well, things start to get weird. They just don't add up. So after that massive $1.1 billion valuation, all the hype, all the headlines, how many of those top-of-the-line NVIDIA H100 GPUs does Starcloud actually have up and running in orbit right now? The answer is one. Just one. And to really put that in perspective for you, a single server rack right here on Earth can hold 8 of those exact same GPUs. A regular old data center has thousands of them. So what they have in orbit right now isn't even a drop in the bucket. It's a tiny fraction of a fraction what's actually needed. And the economics? Oh, they're even worse. Independent analysis shows that doing this in orbit costs about 3 times more for every watt of power. The whole business plan is hanging on SpaceX's Starship rocket, a rocket that, by the way, isn't even in commercial service yet. Heck, even Starcloud's own CEO admits they won't be cost competitive for years.
And if all that wasn't enough, it gets worse. A recent report from the Civi Research Group basically concluded that even if you could solve the money problem, the fundamental physics of it all, we're talking about things like 90-minute eclipse cycles where you lose all your solar power or the constant threat of space debris, it all makes the whole idea of a giant data center network in space a complete fantasy. Which brings us right back to the central mystery. We've got a company with a single GPU in space, its economics are 3 times worse than the competition, it depends on a rocket that's not even flying commercially yet, and there are serious questions about whether the science is even viable. So why on earth did one of the smartest venture firms in the world write them a check this big? Because the investment isn't actually about building data centers in space. Not really. The real bet is on the power of a really, really good story.
So, to get this, you need to understand a fascinating concept called a narrative hedge. It's basically when you invest in a really compelling, futuristic plan B, not because you're sure it's going to work anytime soon, but because you need it to protect your much, much larger plan A from falling apart if people start to lose faith. And this explains the logic perfectly. Look, the whole multi-trillion-dollar AI industry is priced for near infinite growth. But the power grid? That's a hard physical wall. It's a massive bottleneck. And if investors suddenly realize that AI's growth could just stall out for years because of it, valuations would absolutely crater. So what do? You invest in a story, a futuristic escape hatch like orbital computing, to keep that main growth story alive and well. So the bet isn't really that Starcloud will succeed. The bet is that the story of Starcloud is so cool, so futuristic, that it's compelling enough to buy the entire AI industry 2 to 3 more years of confidence from investors, all while everyone on the ground scrambles to fix the real-world infrastructure mess. In this case, the story is the product. All right, so now that we get the clever financial play here, let's talk about what's really at stake. Because this isn't just some smart investment. This is a head-on collision between the hard realities of physics and the flexible narratives of finance. And it has some pretty serious real-world consequences. And here's the biggest risk of all. Every single dollar, every headline, every bit of brainpower that's focused on this high-buzz, high-risk dream of computers in space is a dollar and a headline that is not focused on the low-buzz, high-impact, and kind of boring work of actually modernizing our power grid. The sexy story is literally diverting resources from the essential solution we need right now. So what's the takeaway from all this? Well, if you're an investor, you need to know you're buying a story, not a utility company. If you're a policymaker, all this buzz about space should be a blaring red alarm that the private sector has lost faith that you can build infrastructure fast enough. And if you're a technologist, this is a wake-up call to focus on what actually works today, making things more efficient and finding solutions that can actually get built in the real world. And this all leads to a really crucial point. When a resource as fundamental as computing power becomes this scarce, this contested, controlling how it gets used becomes just as important as building more of it. Accountability stops being boring bureaucracy. It becomes absolutely essential infrastructure itself. And that really leaves us with one final big question to think about. In this massive race to power the future of AI, are we focusing our money and our brain power on building real, tangible solutions? Or are we getting a little too good at just telling ourselves bigger, better, more exciting stories?